Hi everyone. Today let us study few topics related to additional list operation, sparse matrices, double linked list. First topic, that is additional list operations. Introduction to additional list operations. C programming offers various additional operations for manipulating lists. This operation can enhance the functionality and flexibility of list operations. Understanding this additional operations is essential for efficient list manipulation. Insertion operations. Insertion at the beginning of the list allows for efficient addition of elements. Insertion at the end of the list ensures that new elements are appended. Insertion at a specific position within the list provides flexibility in list manipulation. Here example is provided. First, we make a new node, next pointer point towards the head. We make the last node's next pointer pointing towards the new node. Finally, the value of the head pointers has to be updated to the new node being inserted. Deletion operations. Deletion from the beginning of the list allows for efficient removal of the elements. Deletion from the end of the list ensures removal of the last element. Deletion from a specific position within the list provides flexibility in list manipulation. Here, example is provided for deletion in double linked list. Searching operations. Linear search can be performed to find a specific element within the list. Binary search is applicable only for sorted list and offers faster search. Hashing can be used for efficient searching if the list has a larger number of elements. Here, let us look into the example. To search a element 6 in the given list, let us first look into the first node, which is pointing towards 3, and next node it contains 8, and a next node contains 12, and the next node contains 6. So it stops and it says where the sixth element is found. Sorting operations. Sorting the list in ascending order arranges the elements from lowest to highest. Sorting the list in ascending order arranges the element from highest to lowest. Various sorting algorithms such as bubble sort or quick sort can be implemented. Merging operations. Merging two sorted lists creates a single sorted list within all the elements. This operation is useful when dealing with large amount of data. The merged list can be stored in a new list or replace one of the original lists. Reversing operations. Reversing the list changes the order of elements from the original list. This operation can be useful for certain algorithms or data processing tasks. Reversing can be done iteratively or recursively depending on the requirements. Here example is being provided. Concatenation operations. Concatenating two lists combines them into a single list. The resulting list contains all the elements from both original lists. Concatenation can be done in place or by creating a new list. Traversal operations. Traversing a list involves accessing each element one by one. This operation allows for performing actions on each element such as printing or modifying. Different traversal techniques like using a pointer or recursion can be employed. Memory management operations. Memory management operations ensure efficient allocation and deallocation of memory for lists. Dynamic memory allocation is commonly used for creating and resizing lists. Proper memory deallocation is necessary to avoid memory leaks and optimize memory usage. Dynamic memory management employs memory swapping, overlays, multiprogramming with a fixed number of tasks, multiprogramming with a variable number of tasks, and demanding paging. Overlays allow programs larger than the available memory to be executed by partitioning the code and swapping them from the disk to memory. Now let us get into the second topic, that is sparse matrices. Introduction to sparse matrices. Sparse matrices are matrices that contain mostly zero elements. They are used to represent and store large matrices efficiently. In C programming, sparse matrices can be implemented using arrays and linked lists. Example has been provided. In matrices are represented in rows and columns. In this matrix, it consists of 4 rows and 7 columns. Here in row 6 and column 1, the value 9, that is a non-zero element, and in the row 0 and column 5, the value 4 is a non-zero element, and in the row 1 column 2, value 6 is a non-zero element, and in the row 1 column 6, the value 1 is a non-zero element. In the row 2 column 3, the value 5 is a non-zero element. In the row 2, column 6, 1 is the non-zero element. In the row 3, column 6, 3 is a non-zero element. And in the row 4, column 2, value 6 is a non-zero element. Representing sparse matrices. One common way to represent sparse matrices is the compressed sparse row format. In compressed sparse row format, three arrays are used: values, row index, and column index. The values array stores the non-zero elements of the matrix. Creating and initializing a sparse matrix. To create a sparse matrix in C, declare the required arrays and variables, initializing the row index arrays with the starting index of the each row, initializing the column index array with the column index of each non-zero elements. Accessing and modifying elements. To access an element in the sparse matrix, use the row and column indices. Retrieve the starting index of the row from the row index array. Iterate through the values array using the starting index and column index to find the desired elements. Accessing array elements. To access an array element, just write array name index. Let us take an example array consisting of 4 indices, that is 0, 1, 2, 3, 4. Accessing the first element of an array is 0. Accessing the second element of an array 1. Advantages of sparse matrices. Sparse matrices save memory by storing only non-zero elements. They reduce computational complexity by skipping unnecessary calculations. Sparse matrices are especially useful for large matrices with a high density of zeros. Now let us get into the third topic and the final topic, that is doubly linked list. Introduction to doubly linked list. A doubly linked list is a data structure that consists of a sequence of elements, each containing a reference to the previous and next element. It allows traversal in both forward and backward directions. The doubly linked list provides efficient insertion and deletion operations compared to other data structure. Here, example has been provided how double linked list representation is done. Structure of a doubly linked list. Each node in a double linked list contains two pointers, one pointing to the previous node, another pointing to the next node. The first node is called the head and the last node is called the tail. In C programming, a double linked list can be implemented using a structure and contains data and two pointers. Operations on a doubly linked list. Traversing. We can traverse a doubly linked list in both forward and backward directions by using the next and previous pointers. Insertion. To insert a new node, we need to adjust the pointers of the adjacent nodes accordingly. Deletion. Deleting a node involves updating the pointers of its adjacent nodes to bypass the node being deleted. Example of a doubly linked list in C. Let's consider a C program that demonstrates the implementation of a doubly linked list. The program includes function to create a new node, insert a node at the beginning, delete a node, display the list. To utilize the concept of structure and pointers to implement the doubly linked list. A doubly linked list is like a singly linked list, only it has a previous pointer, making some operations on the data structure more efficient. The last element, that is tail, will have the next property pointing at null. Code snippet structure definition. The structure definition for a node in a doubly linked list. Struct node in data, struct node, brief, struct node, next. Here the node contains a data and it contains the pointer pointing to the previous node and pointer pointing to the next node. Code snippet inserting a node at the beginning. Function to insert a node at the beginning of a doubly linked list. Void insert at beginning struct node. Your second bullet head int new data struct node. Code snippet deleting a node. Function to delete a specific node from a doubly linked list. Void delete node struct node. Your second bullet head struct node. Conclusion. Doubly linked lists are useful data structures that provide efficient insertion, deletion, traversal operations. They allow bidirectional traversal and maintain reference to both the previous and next nodes. Understanding the implementation of a doubly linked list in C can help in solving various programming problems efficiently. Here, doubly linked list representation is done. A doubly linked list is like a singly linked list, only it has a previous pointer, making some operations on the data structure more efficient. The last element, that is tail, will have the next property pointing at null. Thank you for watching this video.